Our project uses concrete as a lens to question the current life cycle of building materials and to reframe our city as a quarry, a site of continuous production and deterioration. We materialize Walter Benjamin's questioning of eternal progress in concrete, the material of urban growth, and ask how we can shift our practices to not only anticipate adaptation, but to design for it, to look backward and forward at the same time, and deny the finished state in hopes that creating a design continuum allows us imagination and foresight. With concrete as our primary tool, we look to Jane Bennett's Vibrant Matter to consider material as an active agent in the city. When we conjure an image of a typical modern city, concrete often makes up a large part of that image. Concrete jungle, concrete megastructures, concrete pavement. Concrete is everywhere. And in the architectural community, the material has come to be vilified as a relic of ill-intentioned modernist experiments, and more recently, as a contributor of 8% of the world's CO2 emissions. As the most popular construction material in the world, its scale of production makes it an ethically and environmentally problematic product. Yet concrete isn't likely to go anywhere soon, and we don't want it to. It's a staple of our civic identity. It has allowed us to make major strides in engineering. Currently, material scientists are developing technologies that would make concrete more sustainable through an array of strategies, including substituting cement with fly ash and crushed recycled glass, increasing concrete's porosity, and even growing concrete using bacteria. These new technologies indicate that concrete can be an adaptable material. What if its life cycle could be extended? What if its deterioration could feed future projects and reuse designed into the concrete product itself? To explore this alternative timeline, we situate ourselves within Newtown Creek, a deindustrialized coastal site in New York City. We configure Newtown Creek's existing recycling, wastewater management, and concrete production sites to work as a large-scale device for our proposed cycle of production and deconstruction within the city. We explore deployment and redeployments of concrete sit panels, porous concrete, and e-concrete cladding over time in the built environment, specifically in Newtown Creek. Engaging with the particularities of Newtown Creek, canal, seawalls, floodplain, factory buildings, and open vacant spaces, we approach the site as our stage upon which to experiment with extending material life cycles. This project is a continuum, a set of practices that transforms our site in Newtown Creek over time. In present-day Newtown Creek, existing factory buildings and vacant lots dominate the site. On our site, a precast concrete factory is the starting point of our process of design for disassembly. Now let's project ourselves 30 years into the future, where a localized infrastructure has been established to deconstruct, transport, store, and manufacture the city's building stock as it exits its life of serviceability. Measures are put in place to divert material from entering the waste stream, to be redeployed in another form with another purpose. We use Newtown Creek as an experimental stage for new configurations of concrete, both new and reused, that allows contractors, architects, and engineers to build trust in these new processes and see how these materials actually perform. In addition to the site functioning as a space for quarry and assembly processes, it can also serve as a site for production and regeneration. Smaller scale blocks and scrap concrete pieces participate in the transmutation of urban topography and function as a material in designing sites where new materials can be grown. In a speculative future where our collective consciousness is more concerned about carbon sequestration and sea level rise, the way in which we approach materials will shift from our typical understanding of sustainability. Building with ecological systems in mind and designing for uncertainty are integral aspects of the paradigm shift. We envision our site using waste material and hemp hurd to grow potential concrete alternatives, integrating new forms of labor within this system. The site is continuously becoming neither old nor new, It evolves gradually alongside the shifting values of our culture. And as environmental and economic systems transmute, so does the site. It maintains its manufacturing identity while fostering areas for experimental biomaterial growth at a local scale. Within this evolution, materials from the on-site factory are disassembled and repurposed at the creek's edge to encourage habitat growth, as well as the site's own adaptability to climate change. The production and labor of this design for disassembly process is partially housed in a proposed concrete factory, where new material mixes are created and custom and standard precast slabs are assembled, disassembled, and broken down. The factory offers a more climate-controlled environment, safer working conditions, and more consistent material outcomes. Pieces are put onto barges and trucks and distributed to their next life within the city. The factory building is itself constructed of concrete SIP panels and clad in biophilic concrete panels, all of which use dry joints and are easily disassemblable to allow for their continued use in new contexts. Like a machine, parts can be swapped, traded, or reused depending on their design and function. As the material weathers and parts retire their structural capacity, they are designed to redeploy as various landscape adaptations or to feed new construction cycles. Mining the Future develops a system of urban remediation, a process of building and unbuilding that articulates the full lifespan of materials. Through quarrying the modern city for fragments of history to carry into the present, we honor the past and set the stage for a more complete, local, and sustainable future.